All right, this next section here involves graphs as well as the law of sines and cosines. So we're kind of putting two pieces together, but we start with graphs. And we want to look at the basic graph of sine and cosine. Very important that you understand that in the unit circle, we covered a number of different values. So for example, this coordinate started as 1, 0. This coordinate up here was 0, 1. At the 30-degree angle, or pi over 6, we had a root of 3 over 2 and 1/2. And then we had, at the 45-degree angle, we had root of 2 over 2, root of 2 over 2. And then at the 60-degree angle, we had 1/2 and root of 3 over 2. So as we look at those coordinates, sine takes on the y value. And so if I start to map out sine, and I'm going to mark off 2 pi, because that's once around the circle, I'm going to divide it in half to get pi, half again to get pi over 2. And we have 3 pi over 2 would be that. So these represent the 4 different quadrants. Now, what's interesting about this is if you take pi over 2 and you mark it as, say, pi over 6, pi over 4, pi over 3, and then we put some y values up here, such as, that would be 1. This would be 1/2. We have root of 2 over 2, and root of 3 over 2. Let's try and kind of put those in there. I know it gets messy, but you'll get the idea. We don't have to mark those exact. But take a look at the y values. They go 0, 1/2, root of 2 over 2, root of 3 over 2, and then all the way up to 1. So we start at 0, and then 1/2, then root of 2 over 2, root of 3 over 2, and finally we get to 1. And then, as you go around the unit circle, those values go back down. So finally we get to 1, -1, 0. So the y value is 0 at pi. And then it goes below the x-axis and back up. So the important thing to know is that sine starts at 0, and it has this wave shape that exists about it. And it continues like that around the other side. It looks like a wave. Begins at 0, looks like a wave. So we mark it over the interval 0 to 2 pi. That's what we call 1 period. It has a maximum value of +1. That's the biggest value you get in the unit circle. Has a minimum value of -1. The amplitude is 1. And the period is 2 pi. That's how long it takes before it repeats itself. So those are the characteristics of the basic sine graph. The cosine graph, if you look at the difference, I'm going to circle in blue the x values. So cosine starts at 1, then root of 3 over 2, root of 2 over 2, 1, and then 0. And then by the time you get over the other side, then it gets to -1. So what's different about the cosine graph, we still mark off 2 pi. We divide it into 4 parts. The difference is it starts up at 1, and then it drops, bottoms out, and heads back up. So this is the basic cosine graph. Looks almost identical to sine. The only difference is it begins at 1. So over the interval of 0 to 2 pi, it has a maximum value of 1, a minimum value -1. The amplitude is 1, and the period is 2 pi. Period is how often it repeats itself. So if you look, we start up here at 1. When does it finally get back to that spot? Well, a full 2 pi units it takes in order to get to that spot. That's because it's 2 pi is once around the unit circle. The amplitude, that's this distance right here, from its middle of rotation to the top or the middle of its rotation to the bottom. That's what the amplitude means. So we are going to perform some transformations. We're going to look at y is equal to a sine of bx minus c plus d. However, today we're just going to focus on a and b. So if that's your function, the amplitude is the absolute value of a, and the period is 2 pi divided by b. Same thing for cosine. Amplitude is the absolute value of a, period is 2 pi divided by b. We can spend a lot of time on this. We're going to show you the basics of graphing these things. And we're going to start with this guy, y is equal to 3 cosine of x. So the amplitude in this situation is equal to the absolute value of 3, which is 3. The period is equal to 2 pi divided by the number that sits in front of x. The number sitting in front of x is 1, so the period is 2 pi. So I'm going to mark off 2 pi on each side, a positive and a negative. I'm going to divide it into 4 parts. And then I'm going to mark off the amplitude. The amplitude is 3. So I'm going to put 3 above 1, 2, 3, and negative 1, negative 2, negative 3. So notice in this situation, it's cosine, and it doesn't just start at 1, it starts at the maximum or the minimum. So for example, if we said y is equal to 3 cosine of 0, we said that the cosine of 0 is 1. Remember how we said cosine starts at 1? Well, then you're multiplying by 3. So it ends up starting up here. And then we just go through the rotation. Cosine starts up, and then it drops down to the middle. Then it drops down to the bottom. Then it heads back up across the middle, and then it goes back to the top. And we can continue to perform that same cycle and rotation over and over and over again. And we get this for a graph. That's 3 cosine of x. The next one we like to graph is sine of x, negative sine of x, excuse me. The absolute value is equal, or the amplitude is equal to the absolute value of negative 1, which is 1. And the period is equal to 2 pi divided by your b value. B is the number in front of x, or 1, and I get 2 pi. So same thing, we're going to mark off 2 pi and negative 2 pi. Divide it in half to get pi, divide that in half to get pi over 2, and this would then be 3 pi over 2. Negative pi over 2, negative 3 pi over 2. So mark 1, 2, and 3. 1, 2, and 3. Notice that this graph, it just goes up to 1. Sine starts at 0. Now, normally what we would do is we would head up to 1, because that's the amplitude. And then, like so on and so forth. But if you notice, there's a negative in front, and that's going to create a vertical flip. So instead of the dots going like that, instead of starting by going up, it's going to start by going down. That's the graph of negative sine of x. So you can see how it's flipped. You can also see when you compare it to the 3 cosine that we just graphed, it's much smaller. If you look at the next one, 4 sine of pi x, the amplitude is going to be equal to the absolute value of 4. The period is equal to 2 pi divided by the number in front of x. The number in front of x is pi, so you get 2. So the amplitude is 4, the period is 2. So I'm going to mark off 2 and negative 2. Divide 2 in half, I get 1. Divide that in half, I get 1 half. And 3 halves. Negative 1, negative 3 halves, negative 1/2. 1, 2, 3, 4. 1, 2, 3, 4. Sine starts in the middle or at 0, and then it's positive, it's going to head up. It's going to go all the way up to 4, cross back over, head on down to the bottom, and back up. That is one rotation of the sine graph. We're going to show another rotation back here. Amplitude is equal to absolute value of negative 2, which is 2. Period is going to be 2 pi divided by, the number in front of x is 1/3. So we have 2 pi divided by 1/3. When you multiply by the reciprocal, you get 6 pi. Now, this is where everybody says, I don't know how to divide this stuff up. Well, 3 pi divided in half is 3 pi over 2. Now you're like, okay, I get that, but what about the third tick mark? Well, watch me count. Okay, 3 pi over 2. Then we would have 6 pi over 2, which is, hey, oh, the same as 3 pi. Add another one, we get 9 pi over 2. So that's 9 pi over 2. If you'd add another 3 pi over 2, you would get 12 pi over 2, which is, hey, look, 6 pi. So you can see, just simply count by your first tick mark 3 times, or multiply your first tick mark by 3, you'll get that next one. Okay, the amplitude is 2, so I'm going to mark off 1, 2, 3, 4, 1, 2. And so we're going to go ahead and, cosine. Now, if you remember it, if we plug in 0, the cosine of 0 is 1. So negative 2 times 1 is negative 2. So you can see cosine will always start at the maximum or the minimum, whereas sine starts at 0. So cosine is now going to start down there. You see the negative flips it upside down. So then it's going to go up from there. So it's just flipped from what it normally is. You would say normally it wants to start up there at positive 2. Now it starts at negative 2. There's your basics of your cosine graph. Okay. We'll do one more here. I don't think I have these on your assignment, but I just want you to understand the differences. Sketch a graph the following on the same axes. We're going to look at this guy. I see the amplitude is 2 and the period is equal to 2 pi. And here I see the amplitude is 6 and the period is 2 pi over 4 or pi over 2. So watch how I mark this off. We're going to go 2 pi, pi, pi over 2, and 3 pi over 2. Negative 2 pi, negative pi, pi over 2, and 3 pi over 2. So, those are negative. So we often graph things individually. So if you look at these graphs, those are all graphed as just a single graph. But what if you put them on top of each other? How would they compare and contrast? It's important to note some of those changes. I'm going to mark this as a 2, 4, 6. And then negative 2, negative 4, negative 6. There we have it. Now, I'm going to do the top one in blue, and I'll do the bottom one in black. Okay, so if the top one is in blue, it's negative 2 sine, so I'm going to start here, and then I'm going to drop to 2. Back up, and down. I'm going to do that same thing on the other side. Now the difference is, with the next graph, I'm going to go all the way up to 6 and down to negative 6. But look at the period. The period is pi over 2. So that means I have to do one full rotation by the time I get to pi over 2. So I've got to go up, down, and back up by the time I get to pi over 2. So it's going to repeat itself 4 times as often as your first graph. And it looks kind of messy, but if you were to graph this on your graphing calculator, they actually look identical. I should say it looks very similar to what I have right here. And we're going to check that out here in just a second. Okay, so part of what I want to show you is I'm going to turn on my calculator. And it's really cool how you can see these graphs side by side. If I go into y equals, I'm going to type both of these, -2 sine of x. And then after okay, so we got -2 sine of x, and then we're going to have 6 sine of 4x. Type that in, and here's what's really cool is if you, first of all, mode, notice that our x values are set up in radians, not degrees, so you won't be working in degrees or radians when you graph this. So graphs, we will work in radians. The other thing is you press window, my minimum x value is -2 pi. My maximum x value is +2 pi. My minimum y value, or a scale, so scale is your tick mark. Looks like my tick marks are every pi over 2. My y minimum is -6. My y maximum is +6. And my tick mark is every 2. So watch how close your graphs are. So that's the first one that we drew. That's that's the blue one. You can see our drawing is like spot on. Now look at this next one. Exactly like we said, you know, bunch of ups and downs, 4 times what you have for the other one. So although my graph may look really, really sketchy and like, okay, how accurate is that? You can see it's super accurate. So we'll check it out in class. See you soon. Have a good one.